Hello friends, this is Priyanka. Today we are going to solve a problem on given mechanism. In this video we are going to draw the space diagram and velocity diagram with some suitable scale. We are also going to select the direction for the angular velocity of the link from the velocity diagram. So first I will read what is the given problem. In a mechanism shown in diagram, the crank OA is 100 mm long and rotates clockwise about O at 120 rpm. The connecting rod AB is 400 mm long. At point C on AB 150 mm from A, the rod CE 350 mm long is attached. The rod CE slides in a slot and a trunnion at D. The end E is connected by link EF 300 mm long to the horizontally moving slider F. For the mechanism in the position shown, find velocity of F, velocity of sliding of CE in the trunnion, angular velocity of CE. So this was the given question. Now main important thing is that first we have to draw the space diagram with some suitable scale. So if we observe the given dimensions, we have to use here the scale 1:half. Now we will observe the given diagram. So in this diagram, the point O is fixed point and with reference to the point O, there is the point D that we have to select. So how to select? So first we have to locate one particular point O, and from that point we will draw here the horizontal line and vertical line passing through the point O in the form of dash and dot. Because point O is the fixed point and it is the center about which crank rotates, and that's why the line passing through O we have to draw in the form of dash and dot. Now the horizontal distance from the vertical line passing through O we have to take 200 mm and vertical distance we have to take the 300 mm. But our scale is 1:half. That means we have to take vertical distance 150 mm and horizontal distance 100 mm. And then we will select the point D. And if we observe this diagram, then from this point D there is the link C that is getting passed. So this is about the selection of points. So first we have to select the point O as well as point D. Now we will move for the diagram. So here from this point O, the crank OA, the length is given 100 mm. So as per the scale 1:half, we have to take distance 50 mm, that is equal to 5 cm in the scale, and here from this horizontal line there is the angle 30 degree below this horizontal line, and we have to select the point, and then from this O we have to draw one line that is equal to 5 cm. So in this way this crank OA is getting completed. Now the length AB is also given 400 mm. So as per this scale we have to take here as a 200 mm, that is equal to 20 cm. So from point A we have to take a distance 20 cm on this vertical line. So this is the vertical line passing through the point O. So here is the point of intersection, and here we have to take as a slider, and here is that is point B. Then the distance in between point A and C is also given, that is equal to 150 mm. So as per the scale 1:half, we have to take the distance 75 mm, and we have to select here the point C. Now point D is already getting selected. Now from this point C we have to draw one line, but it should be passing through this point D, because at point D there is the trunnion in which there is the oscillation of this link is taking place. So here what is the length CE given? So CE length given 350 mm. That means as per the scale 1:half we have to take 175 mm distance, and we have to draw here the CE. And then again the link AF length is given, that is 300 mm. That means as per the scale 1:half we have to take 150 mm distance, and we have to draw here one line, and we have to draw this line in such a way that point should be intersect on this horizontal line. So we will use here compass also. In the compass, take a distance equal to 15 centimeter. Take here E as a center and mark one arc. So the arc, the point of intersection where this arc is taking with this horizontal line, that will be the point F. So at this point F also we have to draw here as a slider. So in this way the space diagram is getting completed. Now we will move to draw the velocity diagram, but before that we will first calculate the linear velocity of the crank AO. So here NAO 120 rpm. So from that we can calculate the omega, that is angular velocity of AO, that is 2 pi n by 60, which is equal to 4 pi rad per second, and from that we will calculate the velocity. So VAO means what? Velocity of A with respect to O. So point O is the fixed point, so we can also say VA, which is equal to omega AO into length of OA. So this length we have to take in meter. So 4 pi into 0.1, which is equal to 1.26 meter per second. So this is the linear velocity, and we know that this linear velocity is always in perpendicular direction to the link. But in which direction it is perpendicular? So for that, here the rotational direction is given, that is it is in the clockwise direction, and it is shown in the diagram. So we have to draw one perpendicular line to this crank OA. So here I will use protractor. These two edges are perpendicular to each other. So I will align one edge with this link OA, and from the other edge I will draw one perpendicular line passing through this point A. So here this line will indicate us the direction of velocity VA. Now for this velocity of A, this is the direction and magnitude is 1.26 meter per second. So to draw the velocity diagram, we have to take some suitable scale. So we will take here scale 1 meter per second is equal to 20 centimeter. So actual velocity is 1.26 meter per second. So for 1.26 meter per second, here will be question mark. So if we take the cross multiplication, that is 1.26 multiplied by 20, which is equal to, suppose this unknown we will consider x, then x into 1. Then what is the value of x? That is 1.26 into 20, that is 25.2 centimeter. So we have to take scale 25.2 centimeter and we have to take this direction. So first I will select this particular point, that is the point O, because this point O is the fixed point. So I will select here, this is the point O, and I will use the small letter for the velocity diagram. Now I will use this roller for transfer this direction of VA. So I will take the parallel line to this VA and I will draw here one line parallel to VA passing through the point O. So scale is 25.2 centimeters. So here is the final point. So initial point is O, and what is the final point? Final point is A. So I will use here as a small a. So we have to show arrow also. So this is the arrow, and this vector OA represents the velocity of A. So I will use here as a VA. Now again this point A is connected to link AB. So how to indicate the velocity of link AB? So we know that this velocity is in the perpendicular direction to the link. So again I will use protractor and I will draw here. I will align one edge with this link AB, and from the other edge I will draw here one perpendicular line. So this is the perpendicular line. So I have to draw one line parallel to this construction line but passing through the point A. But what about the direction? So currently we don't know direction. So on both sides of A I will draw this line. Now we don't know where is the exact location of this point B. But if we observe at this point B there is the slider, and for this slider which is having reciprocating motion along this vertical line. So I will show here the motion is along this, that is this upward and downward direction. So how we can show this reciprocating motion? So this vertical line, and that is the motion of at this point, or we can say the slider at point P is with respect to the fixed point O. So we know that we have to shift the motion of the slider, that is in a horizontal direction or vertical direction, as it is. So we will show this motion of the slider, that is in this along this vertical line we will shift as it is, and this motion we have to show the line passing through the point O. So I will draw here one vertical line passing through the point O. So we can also take the parallel line to this vertical line from the space diagram. So here is the point of intersection, and this point of intersection is nothing but the point P. So we have to show arrow. So from O to B, O is the initial point and B is the final point. So I have to show arrow, and this line or this vector O to B indicates us the velocity of B, or we can say velocity of slider at B with respect to O. So I will show that it is just VB or VBO. And then what this vector AB indicates, so here we have to show arrow. A is the initial point, B is the final point. So this vector indicates us the velocity of B with respect to point A. So I will say that VBA. Now we know that from the space diagram on this link AB there is the particular point, that is the point C, and we have to locate this point C on this vector AB. So how to locate? So for that we will take ratio. So from space diagram we can write that AC by AB, which is equal to AC by AB. So here location of C in the velocity diagram is not known, but the length of AB is known. So I will write here what is the length of AB, that is 16.5 centimeter. So now I will write this. So here write AC by AB, which is equal to AC by AB. So here 16.5. Here the unit is centimeter, and this 150 by 400 is unit is millimeter. But if we observe, this millimeter unit is getting cancelled from the numerator and denominator. Now in this equation only one unknown term, that is AC. So we will calculate this AC. So I will take here 15 multiplied by 16.5 divided by 40, because this 0 is also getting cancelled. So which is equal to 6.18 centimeter. So we can write here, therefore AC is equal to 6.18 centimeter. So we have to take the point C from this point A at a distance of 6.18. So approximately we will take here 6.2 centimeter. So here is the point. So I will locate with the black marker. This is the point C. So in this way this point C is getting completed. Now if we observe here in this trunnion there is the point D. So we have to show the velocity for this link CD. So how to show? So again we know that for this link CD the velocity is in the perpendicular direction. So here will be initial point V is C and final point is D. So first we will draw one perpendicular line. So I will align one edge with this link CD, and from the other edge I will draw here one construction line, that is in the form of dash. So now draw one parallel line but passing through the point C. So here I will take the same line, that is the parallel line, with the help of roller, and I have to transfer this line but passing through the point C. So now here on this line somewhere point D is there. So how to show? So this is important point, because at point D there is the trunnion, and in the trunnion there is the reciprocating motion for this link CD with respect to O. So with respect to fixed point we have to show the reciprocating motion or oscillation motion. So remember that. So when I will draw line parallel to this CD but passing through this point O, I will get the point D. So here I will take one line parallel to this link CD, because this is the motion. This at this point here, this link CD will oscillate along this link CE, or this along this direction. So if I draw here, this is the parallel line. So I have to take the parallel line to this link CD, and here with this parallel line we have to draw one line passing through the point O. So this is the point of intersection, and this point of intersection is nothing but the point D. So I will draw here with the help of black marker. So now we will show the velocities. So this vector O to D. So what this indicates, vector O to D? So it is nothing but it indicates the oscillation motion at point D. That is the velocity at point D. So I will say Vd. So velocity at point D with respect to O. So simply we can say Vd. Now what this CD vector, because initial point is C, final point is D. So this indicates the velocity of D with respect to C. So I will say that this here will be VDC. Now on the extension point of this CD there is somewhere point E. So how to show that, or how to indicate that? So again, if we observe the space diagram, here we will take the ratio. So we will take the ratio CD by CE. So I will take CD by CE, which is equal to, in this diagram, CD divided by CE. Now here this CE link, that is the length of this link CE is given, but the length of this link CD is not given. But here this direction, this space diagram is drawn with the help of scale. So we can measure this value. So first I will take the value of C, that is 175 into 2. Here is CE is 350. And what is the value of CD? So CD, if we measure, we will get here 12.5. That is 250. Which is equal to, now here CD is known. So if I measure this CD, so it is 5.5. And what about CE? So the CE is unknown. So this 250 and 350 is in millimeter, and this 5.5 is in the centimeter. But from the numerator and denominator, this millimeter is getting cancelled. So I will solve this. So CE is the unknown term. So I will take CE to the left hand side. So 5.5 multiplied by 350 divided by 250. So which is equal to 7.7. So I will say that CE is equal to 7.7. So distance of C from E is 7.7. So I have to plot this CE. So here is the point E. So now this is the point E that is getting selected. Now again, from point E there is the link EF. So again we have to show the velocity for this link EF. So how to show that? So we know that velocity is in the perpendicular direction to this link. So I will draw here one perpendicular line, and now draw one parallel line for this construction line, but passing through the point E. So here initial point is E and final point is F. Now we don't know where is the exact direction. So on both sides I will draw here one line. So this is the line. Now we don't know where is the exact location of F, but what is happening at point F? So at point F again there is the slider, and this slides along this horizontal line. So this horizontal line is with respect to fixed point O. So we have to transfer this motion of this slider as it is. That is, we have to transfer this motion along the horizontal line passing through the point O. So I will draw one horizontal line passing through the point O. So here, if I show this is the point of intersection, and this point of intersection is nothing but the point F. So we will give the arrow. So here from O towards F I have to show arrow, and what this vector OF indicates? This vector OF indicates velocity of F with respect to O, or simply we can say VF, and that is nothing but this is the reciprocating motion of this slider F along the horizontal line. And what this EF indicates? So here the initial point is E and final point is F. So it indicates velocity of F with respect to E. So this is the velocity diagram that is getting completed. Now we will move for the calculation part. So what is the first question? So first question is find out the velocity of F. So velocity of F, at point F there is the slider which is having reciprocating motion. So velocity of F, that is we have to find out the motion of this reciprocating motion with respect to point O. So we will measure what is the length of this vector OF. So vector OF is 13.5 centimeter. So here scale is 1 meter per second is equal to 20 centimeter. So here for 13.5 centimeter, what is the velocity? So here is the question mark. So again we will make here cross multiplication, that is 20x, which is equal to 1 into 13.5. Therefore x is equal to 13.5 divided by 20. So which is equal to 0.675 meter per second. So this is the answer. Now second question is that velocity of sliding C in trunnion. So here this is the link C, and at point D there is the trunnion where there is the sliding motion. So this sliding motion is taking place along this line, that is along this inclined line. So this sliding motion, how to measure? So this is getting sliding, the link C is getting sliding with respect to fixed point O. So remember that any reciprocating motion or sliding motion or oscillating motion is taking place with respect to this point O. And this trunnion is at point D. So we have to measure vector O to D. So what is the length of this vector O to D? That is 20.5 centimeter. So with this scale, if we measure what is the velocity, so velocity at this sliding at this point D is equal to 1.025 meters per second. Then the third question is that angular velocity of this link CE. So to measure the angular velocity, we have to first find out the linear velocity. So here is the velocity diagram. So we will measure what is the vector C to E. So it is 7.7 centimeter. So from that, what is the linear velocity? VCE is equal to 0.385 meter per second. So for that we will use this scale, and then from this linear velocity we can calculate the angular velocity omega. So for that length of C is required, and we have to take in meters. So 0.35 meter. So 0.385 divided by 0.35, which is equal to 1.1 radians per second. So this is the answer, that is this is the magnitude. But what about the direction? So we will now decide the direction from the velocity diagram. So if we observe, this is the CE which is in perpendicular direction to the link. So here is the perpendicular line. So I will draw this one perpendicular line. Now the arrow is in the downward direction. So I will show arrow in the same direction. Here it is shown. Now how we can measure the omega CE? That is the omega, that is the angular velocity of C with respect to E. So here with respect to E means we have to take E as a center, and we have to move the compass in the direction of the velocity. So I will move the compass. So I will draw here. So here in this direction, this is the direction of rotation. So this is the direction of rotation in clockwise direction about point E. So how we can write the answer? So we will write here, that is the clockwise about E. So this is the answer.